Hi everyone and welcome back. In the last video, we covered all the Git theory. We talked about what version control is, how Git works under the hood, and why it is such a powerful tool for developers and network automation engineers. If you haven't seen that yet, I really recommend starting there first. You will find the link down in the video description or in the comment below. It will help everything we do in this lab make a lot more sense. So in this lab, we are going to get hands-on with Git and see how it actually works when managing a project locally. So no remote repository yet, just our code and Git on our own machine. Before we dive in, make sure to take a quick screenshot of all the tasks listed on the screen. That way you can follow along step by step with me during the demo. We will start by creating a brand new Git repository from scratch. If Git isn't installed on your system, don't worry, I will show you how to get it installed first. Then we will configure our Git identity. We will compare global and local Git settings and then set up the folder that will hold our new repository. Once everything's ready, we will move to something a bit more practical. We will be committing a Python project that automatically generates VLAN configurations. This is where you will start to see the real power of Git. We will add our files, stage the changes, and make our first commit. And we will do that step by step while also exploring how Git tracks everything in the background. Finally, we will run the Python script, make a few updates, and learn how to manage repository contents effectively. We will look at how to handle modified files and rename folders using Git commands, and even create a gitignore file in order for us to exclude unnecessary files and directories. So by the end of this lab, you will not only know how to set up and manage a local Git repository, but you will also be able to have a working understanding of how Git helps keep your automation projects clean and organized and versioned, the way real developers and network automation engineers do it. And in the next video, we will also tackle the second lab, where we will take it to the next level by pushing our project to GitHub. We will connect the local repository to a remote one. We will work with branches and create pull requests. So basically, everything you need to start collaborating in a professional workflow. So fire up your terminal, open your favorite code editor, and let's get to it. Okay, so I will go through the first task to create a new Git repository, but if Git is not installed on your machine, you could issue the following commands if you are using Ubuntu system, for example. So I will execute sudo apt update. And here we need to put the credentials. Now that we've done that, we can then go ahead and install the actual Git tool. And to do this, we would need to say sudo apt install git. And if you want to verify the version currently set up, we can say git -- version. And here you can see that the Git version that we have installed in our machine is 2.34.1. Okay, now I'm going to create a new directory for our new repository, and I'm going to use the mkdir command for that. And also I'm going to change the current directory to go inside that folder that we just created. Then I will initialize a new Git repository by using the following command. So when you run the git init command, Git sets up all the necessary plumbing in the background to start tracking your project's changes. So what's really interesting here are those hints Git is giving you. So Git is telling you that it's using the master as the default name for your main branch, but it's also letting you know that this is changing in the wider programming community. There has been a shift in the industry to use more natural terms like main instead of master for the primary branch name. The hints are actually quite helpful. They are showing you that you have options here. You could change this globally, so all your future repositories use main from the start, or you could just rename this branch right now if you prefer. The important part is that your empty repository is now ready to go. Git has created that hidden .git folder where it will store all the history and tracking information. Now you can start adding your VLAN generator files, and Git will be watching in the background, ready to help you save snapshots of your progress as you build out your project. Now, let's configure our Git identity by adding our user information globally. So I would run the git config --list command. So if you want to create your own username and your own email, the commands that you need to use are a couple of commands. The first one is git space config space dash global, and then space, you would need to say user dot name, and then you can specify the name. And here we can say IEE, and I can see that I've made a mistake here. I need to actually include another dash. So I'll go back and rectify that. And then I will do the same thing for the email address. So I'm going to use the up arrow to use the previous command. And I'm going to change the user.name to user.email. And in here, I'm going to say info at, and then the domain name, everything everywhere.com. So after that, let's do a quick comparison between the global and local Git configuration information. So I would say git config --list. So what we can see from the output is the Git knows who you are. It has your name stored as IEE and your email address as well. This might seem like a small detail, but it's actually really important. Every time you make a commit, which is like saving a snapshot of your work, Git stamps that commit with your name and email. This creates a clear history of who did what, which becomes incredibly valuable when you are working with others on a project. It's also worth noting that since this is a fresh repository, we are seeing mostly default technical settings. So as you work more with Git, you might add other configurations like custom merge tools or specific branch behaviors or project specific aliases that would appear in this list. So this command gives you a nice way to verify that everything is set up exactly how you expect it to be before you start committing your work. Now let's execute the following command to display the local Git configuration settings. So I will use the same command and I'm going to just add --local. So the output seeing on the screen suggests that we are not in a Git repository in the current folder. So I'm going to say ls-l, and we need to go to VLAN _generator. And inside there, I would need to execute that command once more. So I would say git config --list --local. And here are the local configuration settings specifically for the VLAN generator repository. So Git here shows you the settings that only apply to this particular project rather than your global user settings. Next, I will check the global Git configuration settings. So I will up arrow and I will just remove the local and replace it with global. So now we are looking at your global Git configuration, which acts like your personal user profile across your entire system. When you use the --global flag, Git shows you the settings that apply to every repository you work with on this machine, unless you specifically override them for a particular project. So I need to get the same command, but in this time, I'm going to actually remove the --global, and now I'm going to hit enter. And now what you see on the screen is the combination of Git global configuration settings as well as the local configuration settings for the local repository. Next, let's move to examine the repository structure. So I will run this command, tree-a, and then I'm going to expand the terminal window. So when you run the tree-a command, you are seeing all the hidden files and folders that get created when you initialize the repository. That .git folder is essentially Git's brain. It's where all the magic happens behind the scene to track your project's history and changes. And what's really cool here is that you are looking at a brand new Git repository in its most basic form. You can see all the scaffolding that Git sets up for you automatically. There are folders for storing your actual file content in the objects directory, places to track branches and tags in the refs folder, and even a whole collection of sample scripts in the hook directory that you could customize to automate certain actions. The fact that your main project area outside the .git folder is empty makes perfect sense because you just created this repository and haven't added any files yet. Once you start adding your files, files and documentation, they will appear alongside this .git folder, not inside it. So Git will then use all these internal structures to monitor what you are doing and save your progress when you use the commit command and help you manage different versions of your work. Now let's move to step 1.7 where we need to create an inventory file using the YAML format. So I'm going to type touch inventory.yaml and I'm going to hit enter. Next, I'm going to go ahead and edit that file that we just created. And I'm going to paste this content. And also I'm going to save the file. So let's verify the content of that file from the command line interface. And to do that, we would need to execute the cat command to display the entire file. So I'm going to say cat inventory.yaml. And as you can see, the output on the left-hand side. Now let's use git status to observe which files are not yet tracked. In order for us to do that, we would need to execute the git status command. So what you see on the screen, this is git status output, is giving you a perfect snapshot of where your new repository stands right now. You are currently on the master branch, which is your main working area, and Git is telling you that no commits have been made yet. This makes complete sense since we just created this repository. So the really interesting part is that Git has noticed your inventory.yaml file settings in the project folder. Git is calling this as an untracked file, which means it can see the file exists, but it's not currently monitoring for changes or including it in your project's history. It's like having a document on your disk that you haven't filed yet. So Git can see it's there, but it's not officially part of the repository until you tell Git to start tracking it. The message is actually quite helpful because it's giving you clear instructions on what to do next. If you want to start including this file in your project's history, you would use git add inventory.yaml to let Git know it should start paying attention to it. Once you do that, the file will move from untracked to being ready for your first commit, which would be like making that file permanent entry in your project's history book. So now let's add that file to the repository. So I will execute this command, git add inventory. You would need to actually include the whole file name, not just the name of the file, but also including the extension. So I'm gonna say git add inventory.yaml. So let's go ahead and check the status once more. So as you can see on the screen, you can see the file has moved from the untracked section to the changes to be committed area. This is what Git calls staging a file. The file is now prepared and waiting to become part of your first official project snapshot. So what's really useful is that Git continues to be helpful by giving you a clear instructions. It shows you that this is a new file that is ready to be committed, and it even tells you how to reverse this action if you change your mind. So this staging area is actually one of Git's powerful feature. It lets you carefully choose which changes you want to include in each commit, rather than just saving everything at once. So now you are at a great point. You have your inventory.yaml file staged and ready to go. The next natural step would be to create your first commit, which would permanently save this current state of the file into your project's history. It's like taking that first snapshot that you can always log back to. Okay, so with that being said, let's go ahead and commit the file to the repository. So I will issue this command, git commit space -m. I'm gonna type a message saying add an inventory file. So that message that you're seeing is Git's way of confirming that everything worked perfectly. And let me break down what each part means. So master, again, tells you this commit happened on your main branch, and root-commit is Git's special term for that very first commit in a repository, the foundation that everything else will be built upon. The code that ends with 243 is your commit's unique fingerprint. It's a shortened version of a longer hash that uniquely identifies this specific snapshot. So Git generated this automatically, and it's how Git keeps track of exactly what was in your project at this moment in time. The rest of the message is basically a summary of what changed. One file was added to the repository, which is your inventory.yaml, containing multiple lines of content. Now let's go ahead and check the repository status and log. So I'll say git status. And as you can see, this is Git's way of giving you the all clear signal. When you see the working tree clean, it means that everything in your project folder is currently synchronized with what Git has stored in its history. There are no unsafe changes, so new files waiting to be tracked, and no modifications that haven't been committed yet. This is actually an ideal state to be in when you are between tasks. It means you have successfully completed one unit of work, adding the inventory file, for example, and you are ready to start the next task with a fresh slate. If you were to begin editing existing files or creating new ones, Git would immediately notice those changes and let you know in the next status check. Let's go ahead and execute git log. And the output shows you that this is like looking at the official history book of your project. And right now there is just one entry, but it's an important one. The git log command shows you the timeline of all your commits you have made. And in this case, it's displaying that very first commit you just created. What's really cool here is that we are seeing all the details preserved in the historical record. You can see the complete unique identifier for the commit, that long string starting with C64424, etc., which acts like a fingerprint for this specific snapshot of your project. It shows your name and email as the author, exactly as you configured them earlier, along with the exact date and time when you made the commit. The head master part is Git's way of showing where you currently are in the project's history. Head is like the bookmark pointing to your current position, and it's attached to the master branch. This becomes more meaningful as your project grows and you have multiple branches and commits. Most importantly, you can see the commit message you wrote, which is the add an inventory file, which serves as a clear, human-readable description of what this change was about. This is why good commit messages are so valuable. They help you and others understand the purpose of each change weeks or months later without having to dig through the actual code changes. It is quite satisfying to see this clean, organized history starting to take shape. Every new commit you make will add another entry to this log, building a comprehensive story of how your VLAN generator project evolved over time. So at this point in time, we have completed task 1, and I'm going to move to task number 2. And the first step is to create a new Python file that will generate VLANs for our network devices. So I'm going to say touch VLAN underscore generator.py, and I'm going to hit enter. And then I'm going to add the following code to the file, and I will save the file. So this Python script is called VLAN Configuration Generator, and its main job is to automatically generate VLAN configuration files for one or more network devices listed in the inventory file. Instead of manually typing VLAN commands for each switch or router, this script does it all for you cleanly and consistently and automatically. So I won't go through each line of the code in this video, since our main focus here is Git. But if you would like to dive deeper and understand exactly how this script works, feel free to check out my blog. I have included the link in the video description below. Now let's add the Python file to the Git repository. So I'm going to say git add VLAN underscore generator.py. I'm going to hit enter. Now let's look at the Git status. You can see the file now has been moved from untracked to staged. So what I'll do next, I will execute the Python script. So I will type Python 3 space VLAN underscore generator.py, and I'm going to hit enter. And you can see that there is an output folder has been created. And now we can go ahead and look at the output folder and see its content. So I would say cat output, and we're going to specify the name of the file. And I'm going to hit enter. And as you can see, these are the VLAN configurations that we have generated by the script. So with that being done, let's move to step number 4, where we need to check the current Git status. So as you can see, the folder output and all the content underneath it has not been tracked, and Git is able to recognize that. So what we need to do next, we would need to add the contents in that folder to Git. So I would say git add output, and we're going to specify the name of the file. And again, let's go ahead and issue the git status command. As you can see that both files and the directory has been moved into the staged area. Please notice that when we added the file, Git automatically also tracks its parent folder. Now let's modify the Python script by adding a comment or making a small change, for example. So I'm going to modify the very first comment section. So here I have inserted a new comment where I have said test line in line number 5. Now I'm going to go back to the command line interface and I will check the git status once more. So I'm going to say git status. We actually forgot to save the file, so let's go ahead and do that. So those changes that we just made have not been staged for commit yet. Now I will go ahead and issue the following git command to see the difference between the previous version and the current one. So I'm going to say git diff VLAN underscore generator.py. And as you can see on the screen, this is Git showing you exactly what changes you have made to your VLAN generator.py file since the last time you have committed your work. The git diff command is like having a careful editor that highlights every single modification. And it's also showing you that you have made a couple of small tweaks to the documentation comments at the top of the file. So the output might look a bit technical at first glance, but it's actually quite readable once you understand the actual format. So the lines starting with minus signs show what the file used to contain that original comment about generate VLAN configurations, and the lines with plus signs, usually green, show what you have changed it to. Now it says generates VLAN configs, and we also have added a new test line comment. So what's really useful about this view is that it shows you the context too. The fact that it went from 7 to 8 lines makes sense because you've added one new line, and this is Git's way of letting you review your changes before deciding to commit them. It's perfect for catching little typos or making sure you are only including the changes you actually intended to make. Once you're happy with these modifications, you could stage and commit them to add this updated version to your project's history. So now let's move to step number 2.8, where we need to add the updated files to the Git index using git add dot. So I would say git add dot. And when you use this git command, you are telling Git to stage all the changes in your current directory and all its subdirectories. So the period key is shorthand for everything in this location. This command is particularly handy when you have made several related changes across multiple files and you want to commit them all together as one logical unit of work. It saves you from having to add each file individually. After running this, if you were to check Git status again, you would see all these changes moved from the unstaged area to the changes to be committed section, ready for you to create your next commit with git commit. So I'm going to go ahead and hit the carriage return. And now let's check the status once more. You can see that multiple files have been added to the staging area and would be ready to be committed. Now I will go ahead and commit the updated file. So I'm going to say git commit -m, and here I'm going to say add Python file and output folder. Now let's go ahead and issue the git status once more. Again, we are working on a clean tree. Let's go ahead and execute git log. And as you can see from the screen, we have made 2 commits, and the latest one is where we added Python file and output folder. Next, let's see what happens when we rename the output folder using the git command. So I will type git mv for move output to configs. And now I'm going to say ls-l. You would see that the output folder has changed to configs. And if I issue git status, you will be able to see that the folder has been renamed from output to configs. So I'm going to say git add all or dot, and then git commit -m, and I'm going to provide a comment where I'm going to say renamed the folder from output to configs. Now let's go ahead and issue git status. And as you can see, we are working on a clean tree. So with that being done, we have completed task 2. Let's move to the final task for this video, where we need to go ahead and modify the inventory.yaml file to add the following device. So I could go ahead and edit the file from the VS Code, but this time I'm going to use a utility called vim. So I'm going to type vim and then the name of the file, which is inventory.yaml. And in here, I am going to add the following device. So in order for you to insert or type using the Vim editor, you would need to hit the I key. So it changes to insert mode. And once you are done, you just hit the escape button and then you hit the shift colon, and then you need to say WQ for saving and quit, or writing and quit. So now that we've made our changes, let's verify our work by revealing the output by saying cat inventory.yaml. And you can see that we've added access switch 1 and the type of that device is Cisco iOS. So now we can go ahead and run the Python script once more and review the content of the configuration folder. But before we do that, we would need to actually change the folder from output to configs. So I'm going to go ahead here and I'm going to say configs, and I'm going to save the file. And then I'll go ahead and say Python 3 VLAN _generator.py. Next, let's execute the tree command. And as you can see under configs, we have generated a new config file for access switch 1. So now we can go ahead and issue the git status command. So as you can see from the screen, we have made some changes to inventory.yaml where we added a new device. We also have changed the VLAN generator where we have changed the path from output to configs. And also we have added a new file where you can see is not being tracked yet. So let's go ahead and execute the commands that we've learned early to add these changes to Git repository. So I'm going to say git commit -m. And here I'm going to set a meaningful message. So I'm going to say added a new config file. So as you can see from the output, Git is telling me that these two files, inventory.yaml and VLAN generator.py, are not being staged yet, so we cannot commit them. And also the access switch VLAN config is not being tracked, so I need to add all of them in one go and then do the commit. So I'm going to say git add, and then I'm going to include the dot to include everything. And then I'm going to use the same command to actually commit the changes. Now, if we say git status, you would see that we are working on a clean tree. So the next step is we need to create a gitignore file to exclude a folder named temp, for example, and we will commit the changes. So in order for us to do that, we would need to say touch.gitignore. So let's modify that file. Again, I'm going to use the Vim editor. Okay, so I'm going to go ahead and hit the I key to insert, and I'm going to say temp, and I'm going to save the file. And at the moment, Git should really ignore a folder or a file called temp. So what I'm going to do next, I'm going to actually make a folder called temp. So I'll go ahead and create a new file under temp directory. So I would say touch temp, and I'm going to say, for example, file _01.txt, and let's modify it if we want. So I can go ahead and say vim temp file 01.txt. And inside, I'm going to say this is a test. I'll save the changes and I will exit. So now if I say cat temp file01, you would see the changes there. However, this is where the magic happens. Now let's see if this file has been ignored by Git or not. So I'm going to say git status. And of course, we actually haven't added the git ignore into the repository, so we would need to do that. But as you can see, that folder that we created is not being tracked by Git. So I'm going to go ahead and add the .git ignore. So I'm going to say git add .git ignore, and I'm going to say git commit -m, and here I will specify that I'm adding git ignore file, and I'm going to hit enter. And now let's say git status, and you can see that we are working on a clean tree. And if I were to go ahead and create another file, so I'm going to say touch temp file _02, for example, and let's add some content to it. And I'm going to save the file. Now let's issue the git status. And you can see that Git is ignoring that folder as well as all the files underneath that folder. So with that being said, that brings us to the end of Lab 1. We have covered a tremendous amount of ground. Let's take a moment to review the foundational workflow we have built together so far. So in our first phase, we started from absolute zero. We ensured Git was installed, created our repository with Git in it, and most importantly, configured our identity. We also peeked under the hood with the tree-a command, seeing the magical .git folder where all the version control magic happens. Then we have moved into the core loop of develop and track. This is the heartbeat of daily Git usage. We've learned the essential cycle, and we brought this cycle to life by watching our Python script run, seeing it creates actual network configurations, and then thoughtfully committing those results. Finally, we have learned to refine and organize. This is where we've moved from basic tracking to professional repository management. We've used Git MV to professionally rename folders, ensuring Git understand it was a move, not a deletion and recreation. We experienced the power of Git diff to review our changes before committing them, and we also mastered one of Git's most important features, the git ignore file. So by creating the git ignore, we told Git to stop paying attention to the temp folder. This is a crucial practice as it keeps our repository clean by automatically excluding build artifacts, temporary files, and other clutter that don't belong in version control. So what's the big picture? You are no longer just saving files, you are now building a project timeline. Every commit is a snapshot you can always return to. Working with precisions, the staging area lets you craft perfect logical commits, and maintaining a clean workspace. So git ignore automatically filters out the noise. And understanding the tool itself, you know what happens under the hood when you run git init or git add. So the VLAN configuration generator was more than just a Python script. It was a real world project that gave us a reason to use Git. So you have now laid the groundwork for everything that comes next. For example, branching and collaborating on GitHub and resolving merge conflicts. So this local repository is your safe space to practice and make mistakes. So everything you've learned here is the absolute foundation for all advanced Git operations. If you have any questions about what we have covered in this lab, whether it's about the staging area, writing commit messages, or how git ignore works, please drop them in the comment below. So that's it for this video. I hope it was informative for you, and if you found it helpful, please don't forget to give it a thumbs up, and if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions or thoughts, feel free to drop a comment below, and to read more about this topic, be sure to check out my blog. You will find the link in the description below. And remember, consistency and hands-on practice are key to success, so stay curious, stay inspired, and until next time, peace.